Here's problem 2317. A particle charged 4 millicoulombs, mass 50 grams, has a velocity 25 meters per second in the positive x direction. When it first enters a region where the electric field is uniform, 60 newtons per coulomb in the positive y direction. What's the speed of the particle 5 seconds after it enters this region? Okay, a little bit more clear statement of the problem than some of the previous problems. We have a velocity in the x direction, initial velocity, 25 meters per second. We have a particle, mass is 50 grams, and charge is 4 millicoulombs. And we have an E field in the positive y direction, and that's equal to 60 newtons per coulomb. So we will have an acceleration in the y direction. Let's figure out what that is. That's going to be the charge to mass ratio times the E field in that y direction. So that's going to be equal to the charge, 4 millicoulombs, over the mass, 50 grams, times the E field, which is 60 newtons per coulomb. 10 to the minus 3's cancel out. 60 divided by 50 is 1.2. Multiply that by 4, 4.8 meters per second squared. So we have a two-dimensional kinematic problem with an acceleration in the y direction of 4.8 meters per second squared. Sounds good. So our final velocity in the y direction will be given by the kinematic formula, kinematic equation number 1 in the y direction. That's going to equal our initial velocity in the y direction, which is 0, plus 4.8 times 5 seconds, which will give us 24 meters per second. So we're going to end up with a situation after 5 seconds where we're still going with an x velocity of 25, and then at that moment our y velocity is 24, and our net velocity then is the vector sum of these two. So the magnitude of that vector will be, by Pythagorean theorem, since these are perpendicular, the square of each component add together square root. So our speed is going to equal v sub x squared plus v sub y squared square root, which is going to be 25 squared plus 24 squared square root, and that will be our speed. 34.66, so we'll say 34.7 meters per second. So after 5 seconds, adding our two component velocities, we have a speed of 34.7 meters per second 5 seconds after the particle enters the region.